In the mechanical intermediate modifying devices, there are some problems like inertia and backlash. In order to eliminate that, we have defined electrical intermediate modifying devices. Electrical intermediate modifying devices are the one which has an electrical circuit, and the change in resistance will be directly proportional to voltage or current. Sometimes in some of the applications, we need different types of voltages. So if the circuit board is operating at 5 voltage, we need 12 voltage. So in that cases, we will be using voltage dividing circuits. Let us see one by one in detail. For your syllabus point of view, there are only two things. One is simple current sensitive device and another one is simple voltage sensitive device. That means here the voltage is being sensed based on the change in resistance, whereas in current sensitive circuit, the current is being sensed with the change of resistance. That means in current sensitive, the current is sensitive to change in resistance. In voltage sensitive, voltage is sensitive to change in resistance. Any corresponding to change of resistance, the voltage or current will be changing. Let us see how to derive the expressions. So this is a simple current sensitive devices. What we are designing is this one, intermediate modifying devices. That means by taking terminating device into consideration, we will be designing intermediate modifying devices. If the terminating device is just a pointer or just a scale, for that I need to use some amplification. If amplification is needed more, then I cannot use this. I have to choose other type of devices. If the amplification is done only based on voltage, then I have to choose voltage amplification as an intermediate devices. If I want high power, high impedance, so I need to design for impedance or power amplifier I need to design as an intermediate modifying devices. These two are very important design consideration while considering electrical intermediate modifying devices. There are two things, one is voltage amplification and another one is power amplification. Let us take this circuit. This circuit consists of a resistance. Rm is nothing but it is a maximum resistance of a transducer. Then this is a current indicator to sense output current. So whenever the output current is being sensed, this indicator will be showing some reading. Then this is the K into RT, it is a potentiometer or it is just a variable resistance. It is just like a rheostat resistance of a measuring circuit. So a measuring circuit will be changing frequently. Hence I need to have a device in order to measure those change in measuring circuit. That means change in variations. So since there is a change in variations, I have used rheostat. Rheostat having resistance will be changing intermediately. So whenever there is a change in rheostat or a resistance, then the current indicator will be changing because this is sensitive to this change in resistance, thereby the fluctuation will be happening or amplification will be happening. Let us see how the amplification will be happening in case of current sensitive circuit. First, according to the Ohm's law states that the voltage is directly proportional to the current. So voltage, I will take it as output voltage, will be equal to current into resistance. So here I have to consider resistance, effective resistance in series. These two are in series, KRT and Km. So since they are in series, what I will do is, I will take this as I0, that is measuring current here. Variable is the current because it is a current sensitive circuit. So equivalent resistance in series is nothing but this is Rm plus K into RT. Whenever there are resistance in series, you can add up. Whenever there are parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. The same considerations. This is the expression for E0. So what I want is, what is the output current? So I0 will be equal to E0 divided by Rm plus K into RT. So this is the output current which is measured in terms of resistance. So many of the cases, this output current what we have measured, that is corresponding to this voltage, this is called as EI. EI is nothing but input voltage. Most of you do this mistake, since it is output current, you will be taking output voltage into considerations. No, it is input voltage. Very important thing. Don't commit this mistake in examination. This is input voltage, EI. Then I want maximum current. How to get maximum current? For maximum current, where I will get a maximum current? If there is no variation in the potentiometer, then I will get maximum current. So for that, the condition will be K is equal to 0. If K is equal to 0, I will get maximum resistance. So what is the expression for that is I max. The same equation make K is equal to 0, so it will be EI divided by RM. So I want change in variation of current. Change in variation of current is nothing but I naught divided by I max. This I will call it as 1 and this I will call it as 2. If I take the ratio of this, so I naught divided by I max will be equal to, what is this I naught? This term EI divided by RM plus K into RT into denominator I will reverse it, RM divided by EI. So this will get cancels. What is the remaining expression is RM divided by RM plus K into RT. This is the expression for variation of current in terms of resistance. So in other words, what we can say is, as the resistance changes, current is also being changed. So let us see how to derive this further. I will make this as a constant and I naught by I max. In the numerator, if I take RM as a common, denominator if I take RM as a common, numerator and denominator will get cancels. It will be 1 plus K into RT by RM. So this is the expression for resistance. I will write this. I naught by I max will be equal to 1 divided by 1 plus K RT by RM. This is the equation for change in current in terms of resistance. So here what I have done, I have taken RM as common. I will show this step here. These two will get cancels and this is a final expression. You have to observe where is the term RT by RM. RT by RM. So this RT by RM is the input resistance. It is the input resistance. If you change RT by RM, if you give RT by RM as a 0, if you give RT by RM as 0.5, 1, so what will be the value of current? From this expression, RT by RM is in denominator. Since it is in denominator, as you increase RT by RM here, the current will be decreased. So, if you increase RT by RM, then I naught by I max will get reduced. So, see the value for 0.5, it is having a maximum value. 1, it is reduced. 2, it is reduced. 4, it is reduced. So, as you increase the value of ratio of resistance RT by RM, the value of I naught by I max will be reducing. What is the meaning of this? If you want low sensitive current, if you want lower current, then the resistance selected should be very high. So whenever you want to make I naught by I max as a sensitive means for the small variation of change in input, the output will be there or output will be fluctuated. So you need to select the value of RT by Rm as high. In other words, this will have more resistance. You have to select in such a way that RT should be greater than Rm. RT means this value should be greater than this value. Practically, it may not feasible always. Whenever you want an voltage gain, this value should be less, this value should be high. V is equal to IR, and then if you increase high, the current value, the voltage will be also high. So here it is only sensitive for current, but you cannot do more amplification. More amplification cannot be obtained in a current sensitive circuit. If you want more amplification, you have to choose the value of RT by Rm to the greater extent. So this may not feasible in all the times, but whenever voltage amplification is not required, just a proportional input has to be varied, then we can use this type of current sensitive circuit. This is the limitation of current sensitive circuit. In other words, the value of impedance transformation cannot be done here also. Impedance is corresponding to AC voltage. Whenever you will be driving an AC voltage, this value will be high. Because of this, the resistance may drops, and it may leads to disturbance set up in the medium. Because of the disturbance, it may sensitive to current, and the disturbance should be eliminated here. That is one of the limitation of current sensitive circuit. Let us see what is this Ballast circuit or voltage sensitive circuit. As the name itself indicates, voltage sensitive circuit, the input variation will be changing the voltage. In other words, the output is sensitive to variation in resistance. This variation in resistance is some parameter here. It is an analogous thing what we have defined here. Let us see the derivation or an expression for Ballast circuit. Again same thing. What is the voltage here? Here RB is the Ballast circuit and EI is the input voltage. Again same thing. Input voltage is directly proportional to current according to the Ohm's law. When you take up the constant outside, it will be current into resistance. Here also we will consider RB and K into RT. Those two are the resistance. And remember, whenever you are calculating the voltage, you have to connect parallel. When you are operating a current, that should be in series. These two are the very important thing here. You need to remember. If you miss this, you will miss the marks. Very important thing here. So let us see what is this RS. RS is nothing but again RB plus K into RT, because those two are in series. So current into RB plus K into RT. And here the current what we are measuring here is an output current which is proportional to output voltage. So this is EI, and I want an expression for E naught. What is E naught? E naught. Whenever we will be measuring the voltage, for the voltage this resistance must be 0. So I naught into K into RT. The condition for this is RB must be equal to 0. And then after getting these two, let us take the ratio of output by input. So if you take E naught by EI, what will be the E naught? E naught is equal to I naught into K into RT divided by I naught into RB plus K into RT. So you will get out RT divided by RB plus K into RT. This is the expression for the ratio of change in voltages. Again, I will be simplifying this K into RT by RB. I will send RB inside and I will take the common factor as an RB. So denominator RB will go inside. So it will be 1 plus K into RT by RB. So this is an expression for the Ballast circuit. Ballast circuit is a voltage sensitive circuit. The expression for voltage will be written in terms of resistance. So I will write the same thing. E0 by EI will be equal to K into RT by RB divided by 1 plus K into RT by RB. Again here RT by RB is a numerator. Whenever you increase the value of RT by RB, the voltage will be sensed. The voltage will also increases. So how far you can increase? Meanwhile, if you increase more than beyond some value, the denominator will also get increased. So this means the impedance of the circuit may be affected because of larger variations of resistance. Here, larger variation of RT by RB leads to sensitive to the change in voltages. So this is the value what we have seen. For 0.5, E0 by EI is less. For 1, E0 by EI is slightly more. For 2, it is more. As you change the resistances, the voltage is also being changed. That means here one can achieve voltage amplification and power amplification. Again, choosing RT by RB is also one of the factor here. The RT should be more and RB should be less. In all the practical systems this is possible. The measurement transducer will be having more resistance. More resistance is given for more flexibility to measure the input. Also less resistance is given for Ballast circuit, and this will hold good for the measurement also, and the hysteresis loss will be less compared to voltage sensitive current sensitive circuit. Voltage sensitive circuit is best compared to current sensitive circuit. The major limitation in the electrical intermediating modifying device is, one is, if we want to achieve higher voltage or voltage amplification, the resistance will be high. That leads to high impedance. Because of high impedance, the circuit may get damages. That is one of the limitation in electrical intermediate modifying devices. In other words, if we obtain high impedance transformation, the voltage will be reduced. So these two cannot be achieved in a single short circuit. In order to overcome the limitation of electrical intermediate modifying devices, we have described electronic intermediate modifying devices. The name itself indicates electronic intermediate modifying devices. It is based on movement of ions from cathode to anode. Cathode is a good emitter of electrons, anode is a good attractor of electrons. Based on the movement of electrons from cathode to anode, it will create some potential difference. Because of this, electrical parameters like voltage or current can be easily achieved. Voltage amplification and impedance transformation is one of the important in case of electronic amplifier. These two are the very advantages, and these two can achieve in a single short circuit. Whenever we need any voltage amplification, the voltage is being increased. Anyhow, the movement of ions from cathode to anode, the rate we can vary based on the power supply given to the cathode. Whenever we energize the cathode, the movement of electrons can be controlled. The control of movement of electrons leads to control in voltage. If you want to more voltage, give more movement of electrons, so that is a flexible to handle the voltage amplification. Whenever we want impedance transformation or high resistance, or in other words high power in the circuit, power amplifiers will be used. In the power amplifiers, the multi-stage amplifiers will be used. Because of that, the impedance of the circuit can be increased without altering any voltage amplification. That is one of the advantage of electronic amplifiers. Let us see what are the general principles of ideal electronic amplifier. If they ask in exam, what are the general principles for ideal electronic amplifier? You have to write this. Number one is infinite input impedance. That means it may have infinite resistance. The resistance will be high, because of which you can bring current to a very low factors. That is one of the advantage. And infinite gain. Since the value of resistance is infinite, the gain also transformed can be infinite. Then low noise. Since the current is being reduced, the noise will be also less. If the current is low, the frequency of the circuit will be low, because of which the noise will be also low. Very advantage in case of electronic amplifiers. There will be no noise compared to electrical or mechanical intermediate modifying devices. Then it will give instant response. The response time is 0. It will give very short range of instantaneous response. Because of this, it is not so sensitive to other external disturbances. That is one of the advantage. Then 0 output for 0 input. This is very practical thing what we need in electronic amplifier. Whenever the input is 0, the variations of output must not be detected. Whether if there is any wind, whether if there is any temperature variations, the output must be compulsorily 0. If input is 0, if it is showing some output, adjusting that error is also one of the key factor, and that will be difficult. We cannot perform always that adjustment in case of measurements. If precise instrumentation is required, then 0 input for 0 output is must. Let us see what are the different types of electronic amplifier. So this figure represents the electronic amplifier. Electronic amplifier is also called as vacuum tube amplifier. Here we are using cathode and an anode. Cathode, it is the terminal, and anode is another terminal. Cathode is a negative terminal of a battery, anode is a positive terminal of a battery. When you give a power supply to the cathode, what happens? The electrons from the cathode will move towards the anode. Because of this, the movement of electrons takes place from cathode to anode. In order to control the movement of electrons, there will be a grid. The grid will direct the electrons from cathode to anode. If the direction is straight or if the direction is good, then what happens? The scattering of electron will not take place. In order to avoid scattering of electrons, we will be using grid in between anode and cathode. So plate is assumed to be as anode, cathode is a negative terminal. From the cathode, the electrons will be flowing to the plate, and then the amplifier load will be taking. So this load you can control by the movement of electrons from cathode to anode. There is a heater supply for the cathode in order to release the electrons from cathode. So that is very important thing. When you want to operate higher loads, when you want to lift at higher loads, when voltage is more, then heater supply in the A can vary. You can select higher heating supply in A. And then another circuit, bias circuit is there. Bias circuit will bypasses from the amplifier load to this. Because of this, what happens? High impedance will not get built up in case of electronic amplifier. This is one of the advantage. If the signal input is high, this is biased. This is biased. What happens? Because of which high impedance will not be created. Then plate supply, you are giving supply to the plate. This is having an electric supply, and again there is a electric supply. This differential current will be sensing what is the load, what is the output. That output is proportional to the differential current. Because of that, what happens? The flexibility of voltage amplification will be more. Whenever this is a single stage amplifier circuit, whenever you want more impedance, you add another one. It will be having a power amplifier circuit, because of which the impedance transformation can be higher. So this is the advantage of vacuum tube transform amplifier or electronic amplifier. In the exam, you have to see the question. If they ask vacuum tube, again it is an electronic amplifier. If they ask electronic, it is a vacuum tube amplifier. The only thing is the movement of electrons from cathode to anode. Let us see the different types of electronic amplifiers. There are voltage and power amplifier, AC and DC amplifier, chopper amplifier, carrier amplifier, tuned amplifier, cathode follower amplifier. Voltage and power amplifier is one where the voltage magnification will be getting, and power amplification is also will be getting. Whenever we want phase transformation, power amplifier; whenever we want voltage amplification, voltage amplifier. That's all. AC and DC. If we operate in AC, it is an AC amplifier. If you operate using DC, it is an DC amplifier. If you want to do multi-staging, DC amplifier will be used. Chopper amplifier. Chopper is again a circuit. Whenever you want to operate at different voltages. Say for example, the board is having only 5 volt, but you are operating 12 volt DC motor. How to operate? That is chopper amplifier. The separate circuit will be there as a chopper. Because of that, the frequency of the amplifier will be changing, and that can be crossed beyond the limitation value. That means you can operate greater than the voltage what you have. Then carrier amplifier is, here also you can vary the frequency of the circuit. Whenever you want the same frequency, you will be using carrier amplifier. When the frequency of the circuit is more, then you are using chopper amplifiers. Carrier amplifier is also looks like chopper amplifier, where here you are operating only the frequency circuit. Then tuned amplifier, the name itself is tuned. That means it is modulated. Certain modulation is done with the help of frequency or amplitude, and this is used whenever you have a voltage rectifier or whenever you want to change the voltage or current. Then cathode follower amplifier, this is similar to this. Instead of plate, we are using follower. So the principle of cathode ray oscilloscope is similar to cathode follower amplifier. Thank you.